Hello and welcome to SudoKanard. Let's have a look at this killer Sudoku puzzle by Jakub Hrazdira that was featured in this round of the WPF Sudoku Grand Prix. So it was worth 75 points. That was the second highest pointer in the round, and that's the puzzle with which I started, and I solved it in like 12 minutes, I think. So it wasn't a true struggle, but it wasn't a picnic either. It had its difficulty. So let's start. 23 in 3 cells is 6, 8, 1, and 9. And something we can see is that those regions, those cages, use almost all of the first 2 columns. We know that the sum of the first 2 columns is 90, so let's add 23, 41, 51, 56, 77, 84, so that here is a 6 to get to 90. So those 2 digits have a sum of 9, which can be done in a number of ways. Something interesting here is that those 6 cells have a sum of 25, which means that this plus that is 20. And you see that this cell is a low digit, maximum of 4. 4 would work with 7 and 9. 3 would work with 8 and 9, but 1 or 2 wouldn't work. So this is 3 or 4, that's 1 or 2. And that's with either 7 and 9 or 8 and 9, so there's a 9 somewhere here. And we need 9 more here, won't be with 3. Could be 2 and 7, could be 4 and 5, could be a lot of things actually. Could be 1 and 8. If this is 1 and 8, then we need 2, 3 and 5 here, but that's not saying much. Where else should we look? Well, this here is suspicious. We have 9 cells with a sum of 52. That's interesting. 52 because, well, let's just color those cells. So this region is worth 52. But now, if you take those cells, they are worth 45. And they share all 8 cells here. So the difference between 52 and 45, which is 7, is the difference between this cell and this cell. So this is 7 more, so that's an 8 or a 9. And I think I just removed the coloring. I did it only for the sake of explanation. Well, what next? Something here is happening. That's a total of a 31. So this cell plus this cell is worth 14. And that's interesting because that plus that is 14. So this digit is the same as this one. So what are the options? The options for 15 are 6, 7, 8, 9, but 7 in a 14 cage doesn't work. It would have to repeat the 7. So 7 is not possible here, so this digit is the same as this one, which is 7, 8, 9, and correspondingly, we get here 6, 8, or 5, and here we get 6, 9, or 7. And this plus that is 15. $19 is a big number. And something interesting here is that 7 wouldn't go in a 19 cage. So 7 has to go here in the 19 cage. 7 doesn't go in the 12 cage. I think I was confused in what I said. So we need to add 12 more, and it won't be 5 and 7, obviously. So it will be 4 and 8, or 3 and 9, and I don't think I can choose which one at that point. So something is happening here in the same fashion as what I did in the bottom left. The sum here, oh yes, the sum here is 53. So that's 8 more than this. So this cell is 8 more than this. So this cell is a 9, this is a 1. Now we have 23 here, plus 9, that's 32. So this plus that is 13. So this is either 7, 6, or 4. And this, oh, sorry, is that? Is that correct? Oh, yes, that's correct. And this plus that is 12, actually. Yes, if I make this a 6, then that is an 8, that's 7, and that's a 6, and that breaks. I was just noting that this plus that had to be 12, so this can't be a 6, that's not an 8. That's not an 8 anymore, that's not a 7, so we get a 6, 9 there, and that's not a 6. Right. Oh, this 9 now makes this a 6, that's an 8, that's a 9, and that's a 2 because there was a difference of 7 between those digits. That's a 3, and we said that this plus that is worth 20. So that is worth 19. We can remove the 7. And that seems to be all. Actually, I made a mistake. The digit that is worth 7 more than this is not in this position, it's here. I think it didn't interfere with anything else that I wrote. I think this mistake will be without consequences. Let's just hope. This 7 now can't include a 2, can't include a 6. It has to include an even digit, and that's a 4. So 4 and 3. 3 can't be here. Here it has to be, I need 15 more. 1 has to be somewhere. 1 won't go in 21. The other 2 digits would need to have a sum of 20. That's not possible. So there's a 1 here for a sum of 15. So it will be 1, 6, and 8. So 1 is here. That's a 6, 8 pair. That's a 9. That's an 8. That's a 9. No 9 here. Nice. And the remaining digits here are 2, 5, and 7. 7 can't be in the 12 cage, so that's 2 and 5, that's 1 and 4. And here the digits are 3, 7, and 9. That's right. This 5 now must be 2 and 3, so this is 5, this is 2. Here we need 7 and 8, and this is actually a 7. So this is 4, this is 9, the sum needed to be 13, so that's a 6, and actually this plus that had to be 14, so I could have gotten this 6 earlier. That's 16, I need another 8 without using 1 or 2, so this is 3 and 5. And that's 1, 2, 6, so 6 here, 1 and 2, that's not a 3. 28 in 4 cells needs an 8, it's not here, it's here, and the remaining 2 cells are either 4, 7 or 5, 6, and because of this 4, It's 5 and 6. This is now 4, 7, 8. But 4 is in one of 4 is not here, just no need to find anything complicated. This 9 makes this a 7, this a 4, this a 9. That's a 7. This 6 makes this a 8, this a 6. Here I need 5, 7, and 9. So this is 5 or 7. 5 or 9, 5, 7 or 9. Here, one's 5 or 7. 1 is here. That's 5 or 7. We already have 9 with 1 and 8, so those two digits have a sum of 9, but this is 2 or 4. But this 10, now, perhaps I should focus on this. I have to do 9 without those digits, could still be 2, 7 or 4, 8. Yes. So I don't think it should be where, well, I don't think I should focus anymore on that. Oh, but that's interesting. I need another 13 here. And 13 in 4 cells needs a 1, because 2, 3, 4, 5 is 14. And 1 can't be here, 1 has to be here. I need another 12 here. There are certainly a number of ways of achieving that. What about this? There has to be a 1 and a 4. 1 here, 4 there. So the remaining two digits must sum to 13 without using 7, without using any of those digits, so they have to be 5 and 8, and because of this 8 is here, and there's a 5 somewhere here. So that's a 9, and that's a 3, and that's a 9. So this is a 1, 4, 5 triple, and we get 2, 8, and 3. That's not 8. They add up to 20, that's correct. Here we need another 10, sorry. Without using 9, 8, or 6, so this is 3 and 7. So that's a 2. 1, 5, and 4. That's the candidates here, not a 5, not a 1. What can this be? 1, 4, 8 seems to work. 1, 5, 7 doesn't work. Oh, so this can't be a 5. 5, 1 would make this a 7, so that's a 4. So 1, 4, 5, 4. No, so that's a 1, that's an 8. And this is 6, this is 8. This is 5, this is 6. 2, 3, and 7 on this row. Oh, I could do the math like in the beginning. I can count how much is the sum of all of this and deduce that by just subtracting the whole sum from 90. First, I just do some cleaning up. Oh, here. The only way, well, 11 doesn't include a 9, so 9 goes here. Those add up to 8 without using 3 or 7, so there must be 2 and 6. There's really no need of doing anything complicated at this point. Here we need 2, 4, and 5. On this column, 1 has to be here. And 4 is now here. This is 2 and 5. so that's not a 2. Up there I get a 5, 2, 3, and 6, so 6 is here. This is 12, 3. 11, I need another 10, so that's a 3, that's a 7, and that's a 2, and 2 here. The remaining digit in this box is a 7. This now is a 3. That's 22 right. That's a 2. 1 and 7 here. 1, 7. Here, 1 there. 5 here, 2 there. 4, and the final digit is a 5, and that's it. So it really wasn't that difficult if you're used to the mechanics, the standard mechanics of Kiro Sudoku. There was nothing out of the ordinary, and by that I'm not meaning it was an easy puzzle. The 75 points were certainly deserved, and that was a very nice puzzle. That the whole round was magnificent. The quality of the puzzle was up there. And thanks for watching this video, and see you soon on SudoKanard.